All right, let's move on to section 1.4, which is a little bit easier than what we've done, and it's almost like a recap of some of the basics of what we've done, really, and then we move towards some word problems later. But let's take a lesson here to learn a little bit more or refresh our memories on the primary trig ratios. All right, so before we begin, I just want to mention that, and when we're in class, I'll mention it in more detail, but there are so many applications of trigonometry, and what we're about to do over the next 3 lessons, there really are a plethora of applications in the real world that vary from video game programming, so trigonometry being in the programming of video games, for example. There's a whole lot of trig in construction, trigonometry in flight engineering as well, okay, and taking into account wind direction and wind speed and your speed in the plane, all deals with trigonometry. There's trigonometry in physics with respect to vectors, modeling mechanics of waves, oscillations, strengths of fields. There's trigonometry actually even in criminology, believe it or not, and we'll get into a little bit more detail in class. Marine biology, marine engineering, navigation. There's all sorts of applications for trigonometry. All right, so there really are a whole lot, and there's more. I didn't list them all, but there's more. But you get the idea that it is something that is used in the real world. All right, and the next 3 lessons in particular are a review, but also very important to know and have knowledge of, and that's why we do it again in this course. So, problems involving primary trig ratios or right triangles in 2 dimensions or 3 dimensions can be solved using your primary trig ratios as well as Pythagorean theorem. So remember, the primary trig ratios, that's your sine, cos, and tan ratios, okay? And the Pythagorean theorem, which I think we all know right off the top of our head by now. Okay, so our Pythagorean theorem, of course, is c squared equals a squared plus b squared. These letters are interchangeable, but as long as what is on the left side of your equal sign is your hypotenuse, okay, that's what you need to really always remember, that students often forget, that has to be your hypotenuse, and a and b are interchangeable. Your primary trig ratios are opposite over hypotenuse for sine. Cos theta is adjacent over hypotenuse, and then tan theta is equal to the opposite over adjacent side. So how do you remember that? You may, I remember this all the way back from high school, and I'm sure it'll stick in your mind for a very, very long time as well, and that's Sohcahtoa, all right? And so all you really need to know is know how to label this triangle based on the angle of reference. So for example, let's say this was the angle given to us or the angle we needed to find, right? So that either one of those situations is giving us the reference angle. So it's either the angle that's given or the angle that we need to find. And the triangle has to be a 90-degree angle triangle to do any of this stuff. From there, this is our angle of reference. This becomes our opposite side. We always know that the longest side of a triangle is the hypotenuse, and adjacent, which means next to, it's the side that is next to the angle. It's right there on the angle, okay? And so depending on your angle of reference, these labels will change. So if our angle of reference is here, now this becomes our opposite side, right? It's opposite of the reference angle. And then the adjacent becomes this side, and the hypotenuse stays the same, of course. It's always just the longest side. Okay, so let's start off really easy and how to solve these ratios here if we have an unknown. So let's say we have an angle and only one of the sides. Well, we can find the other side. And I think by now, since we've done this a few times in the course, you know that you can cross multiply here to solve for an unknown, because that sine 35 is really over 1. So you get 8 times the sine of 35 degrees. To 1 decimal place, x is equal to 4.6. The x can be in the denominator as well, and you can still cross multiply, and you get x times tan 55 is equal to 8 times 1. Solve for x, so divide out the tan 55. So there's this extra step when the x is in the denominator. Okay, but nothing that we can't handle. It's 5.6. I wouldn't calculate yet here what tan 55 is at this step there, because you're going to lose some accuracy, because you're going to have to get a decimal that you're going to have to round, so you'll lose some accuracy. So just do fully 8 divided by tan 55 in your calculator just to maintain some accuracy. Okay, we did this in our last lesson. How do you solve for the angle if you're given the ratio? All you do is take the inverse of cos in this case, and then 6 divided by 15. 66 degrees to the nearest degree. Okay, very straightforward. Just know how to punch this into your calculator. Make sure you use brackets. So second function tan, bracket 8 divided by 7, close bracket, and hit equals. Okay, there you have it, very easy. All right, and now let's actually get to a question before we do some word problems. All right, so let's say we're given the 35. So we're given the reference angle. When you're given the reference angle, the first thing you do is you've got to label your triangle. This is my opposite, this is my adjacent, and this is my hypotenuse. Clearly, the opposite side is a non-factor for us, right? It's not asking us to solve anything on the opposite side. They're not giving us what the opposite side length is. So clearly, that is a non-factor. Clearly, we are dealing with these two sides. We need to solve for A, and they're giving us the hypotenuse. So what ratio do we use that deals with the hypotenuse and the adjacent side? Cosine. So you go cos theta is adjacent over hypotenuse. Cos of 35 is equal to lowercase a is my adjacent over 15. Cross multiply, right? Cross multiply. You get a is equal to cos 35 times 15. 12.3. And actually, I'm going to round to 12. Why did I round to 12 meters? What you do, if the question doesn't ask you to round to a certain amount of decimal places, what you do is you always look to the values given in the question. If they don't have decimal places, then don't show decimal places in your answer. If there's one decimal place, then show one decimal place in your answer, and so on. Okay? Just a little tip there. All right, so that's an example where you're given the angle, but what if you need to find the angle, like in this question? So this is now our angle of reference because it's what we need to find. So the first thing is you label your triangle. Do I need to do anything with the hypotenuse? No, right? They've given me both the opposite and adjacent side, so that is what I need here. Now choose the proper ratio that has opposite and adjacent. Tan. So we're going to find tan of lowercase a is equal to opposite over adjacent. Okay. A is equal to the tan inverse of 12 divided by 10, or 1.2. Okay, and you get 50 degrees. Okay, pretty straightforward. I mean, look at what I did. I identified the angle of reference. I labeled my triangle accordingly. I circled what I needed or what I needed to find. I crossed off what I didn't need. I chose the ratio that is relevant to my labeling. I subbed all the numbers into the formula, and I solved for the unknown. Let's look at a word problem. Before we get to this word problem, though, there is one thing that I need to discuss with you, and that is the idea of angle of depression, okay, versus angle of elevation. And actually, let's get rid of that line. The angle of depression is the angle that is made with a horizontal looking downwards. So angle of depression, because some of these questions use terms like angle of depression or angle of elevation. Angle of depression is an angle made with a horizontal line or a horizontal downwards. Okay, so imagine your eyes are here. You're looking down at an object down there. So your eyes create this invisible horizontal line and then look downwards. Angle of elevation, okay, imagine your eyes being here now and you're looking up at an object here. So it is an angle, so this is angle of elevation. An angle made with a horizontal looking upwards. Okay, so it's important that we understand that before we do some of these questions, okay? So, example 4. Two office towers are 31.7 meters apart. From the top of the shorter tower, the angle of elevation to the top of the taller tower is 27 degrees. And the angle of depression to the base of the taller tower is 48 degrees. Calculate the height of each tower. Okay, so anytime you do any of these questions, your very first step is to try to draw a diagram. Okay, so we have a shorter tower and we have a larger tower. Okay? They are 31.7 meters apart. From the top of the shorter tower, the angle of elevation to the top of the taller tower, here's your angle of elevation. Remember, it's made with a horizontal. It's made with a horizontal. That's 27 degrees. The angle of depression here is 48 degrees. Okay? Calculate the height of each tower. So let's think this through here. I can actually find the height of this smaller tower right there if I find this height right here. Do you agree with that? Okay. So let's start there. That'll be my step 1. And then I'll worry about finding the taller tower. That once I have this, I can then find this and then add these two answers together and I will get the height of the taller tower. But let's start with the smaller tower. And let's draw the triangle that's relevant here and we'll label it. So it's the 48 degree. This was given to us as 31.7 meters. And this is, let's call it H1. Okay, height 1. Okay, it doesn't matter what you call it there. Based on our angle of reference, let's label opposite, adjacent, hypotenuse. Do I need the hypotenuse? No. What ratio has adjacent and opposite in it? The tan ratio. Sohcahtoa. Okay, so tan theta is opposite over adjacent. Tan of 48 degrees is equal to opposite, which is h1 over 31.7. Okay, cross multiply. I'm going to save a step here, and I'm just going to write the answer. h1 is going to equal tan 48 times 31.7. And that's going to be to 1 decimal place, because in the question they gave me 1 decimal place. I have 35.2 meters. So there's my h1. Okay. Let's find my h2. Okay, won't take too long. And then we'll add up h1 and h2 to get the height of the smaller tower. So the larger tower. Draw your triangle. Always got to draw it, right? You got to label this out or you're going to make a simple mistake. Okay, same thing. Opposite and adjacent again. So it's your tan ratio once again, TOA. Okay, H2 divided by 31.7 this time. Cross multiply. You end up getting tan 27, okay, times 31.7. Okay, and you get 16.2 meters there. All right, now I'm not going to box that answer because that's not really a final answer right now. So now I have to find the total height of the larger tower is going to be h1 plus h2, right? It's going to be this height plus that height. So h1 was 35.2 plus 16.2. Final answer is 51.4 meters. So here is our height of the larger tower. Here is our height of the smaller tower. Always double check the reasonableness of your answer. Okay, and it seems like these look pretty reasonable. So the larger tower is just about 16 meters taller than the smaller one, which makes sense because this angle is only 27 degrees here, which means the person who's standing here potentially looking up here isn't really looking up that high. They're only looking up at an angle of 27 degrees, which only translates into 16 meters taller. Okay? There you have a word problem there that includes angles of depression and elevation, which is good. You have a word problem that obviously just solves for an unknown of a side length if you're given an angle and another side of a right triangle. All right? And always, always, always draw diagrams. Multiple diagrams if you have to. Okay? So don't just draw this. When you get to this point, you should be drawing separate triangles so that you can label them and it doesn't get too cluttered and look too sloppy. Okay? That is it for section 1.4.